Welcome, everyone. We very boldly call that our third annual HPC RSE BOF here. We've got a growing group of people organizing this. I will tell you about them a bit more in a moment. This is our agenda. We're already over time with welcome and introductions, so I'm skipping forward. Just to remind everyone of our code of conduct, please be nice to each other, be respectful, do not interrupt, and of course all the obvious things are stated on here as well. Otherwise, we will ask you to leave. If we are discussing something, please use the Chatham House rule. So do not say so-and-so said so-and-so about this, but say, okay, I've been here and somebody made this statement without mentioning who it was and from which organization. Just so that we can feel comfortable having this discussion, can be comfortable sharing our opinions and being open without thinking, oh, people might tell others about this. Okay, what happened so far? Some of you might have been here 2 years ago when we, for the first time, came together in a satellite event after RSECon24, which was really a bit of a weird situation because the Queen had just died and nobody really knew, is this event happening or is it not happening, and who's allowed to come or not or so. But it did happen, and we had, so Andy as the one having organized the Archer Champions and then the HPC RSE things before lockdown and so on, and Gemma and I as Excalibur KECs, we just had the idea, okay, let's all do this event together. The next year, Ed came in. Where's Ed? I'm not seeing Ed. There's Ed. And we had our first BOF at RSECon. Some of you might have been to the online meetup we held in March, and then we had Nick. There's Nick, who's now leading the Knowledge Exchange Coordinators, Excalibur, helping us with that. And after this event, we had Irene and Thomas. Irene is there, Thomas. Thomas is not here yet, so that's our team now. So we are trying to, think about what we want as an HPC RSE community, organizing events, organizing hopefully more online meetups. And then there have been a couple of things we had been discussing previously, things like it would be good to do better signposting. So we have been talking to the RSE Society whether we can have a presence there. So this is ongoing work, still ongoing, and actually Andy and I have talked about making this our first priority after today, establishing a SIG, an official SIG, HPC RSE SIG under the society, and also thinking about, okay, how can we get more people in here, because previously it was mentioned, okay, who's actually comfortable speaking up in an event like this? How can we be more open to more early career people, and how can we get more different types of people in the room here and in the community? That's the wrap-up slide. Okay. I think I'm done here already, and I'm handing over to Ed.
Thanks, Marion. So we may as well go over the overview of the kind of the structure of what we're going to do today in the morning. So we have, the morning is focused on the technical side. So we're going to have a couple of technical talks and then a panel, which should be really interesting. Have we got the, no, this is Charles's slides coming up. So our first speaker this morning is Charles Ferenbow, who is going to be talking about modernizing the X-ray hydro code. I'll pass over to him in just a second when the slides are ready. Mike. Amazing.
Sounds good. Thank you. It always is.
In terms of questions, if everyone could keep adding the questions to the canopy that they have over time. Is it not working?
I didn't think the canopy was working for questions, so it might have to be questions via the Slack channel instead.
Okay. Well, we'll test out the canopy to start with. If there's issues, then we'll move on to the Slack channel, which we will need to send a link or sort of make sort of easily available. But try out the canopy for starters, but if you can make it clear who the question's for, because obviously we've got a lot of content to get through, a lot of different speakers, and then we'll sort of go from there.
Okay.
Well, that's good, isn't it? Canopy's working, so I'll pass over to Charles. There you go.
Right. Well, good morning, everyone. Thanks for the organizers for giving me a chance to talk. This talk is entitled X-Rage Against the Machines, Preparing an Old Code for an Onslaught of New Platforms. And this is going to be a very high-level, very quick overview of a project that we've been doing for 10 years or so now. Let me give you a little bit of the background. So the code I work on is called X-Rage. It's a radiation hydro code that got its start back in around 1990. The history is a little murky, but it's been around for quite a while. It's about 500,000 lines of source code. Then that is just the source code that we maintain on the project itself. That is not counting a whole bunch of third-party libraries that we pull in, some that are written by other groups in Los Alamos, some that are from outside the lab. So there's a lot that goes into this code. It is historically has been almost entirely Fortran. There's some C and C++. We're gradually moving more C++ into the code. And historically, the code has been MPI paralleled, and that's been our only mode of parallelism. We're starting to introduce some COCOS, and I will have more to say about that later on. And just to give you an idea of some of the things we do with it, there's an asteroid simulation and an inertial confinement fusion capsule implosion, both of which were run using X-Rage. So that gives you an idea of the kind of applications we're doing with the code. And then the machines that we have to run it on. We have an array of standard HPC type CPU clusters, but in recent years we've also had to move to a set of machines that are more diverse architecturally and have stranger and stranger kinds of hardware in them. The trend started in 2015 when we got the Trinity machine, which was the Xeon Phi cores, that many core machine that for the time had far more cores than we were used to dealing with. A few years later we had Sierra, which had the NVIDIA GPUs. First time we tried to deploy to a machine with GPUs. More recently we've gotten Crossroads, which is Intel Sapphire Rapids with high bandwidth memory, so getting used to how to use that is still taking some doing. We have Venado that's just coming in that has the Grace Hopper GPU plus ARM from NVIDIA. And in the next little bit, we're also going to be moving to El Capitan, which is an AMD GPU machine. And so the way the timing has worked out on these machines, we started having to deal with this about 10 years ago, but in the past 18 months or so, we've had to deal with 3 different new platforms coming in, the last 3 on the list here. And having to do that in rapid succession has proved to be a bit of a challenge. Fortunately, some of the work we've been doing leading up to this has helped prepare us for that challenge, and so that's going to be the main subject of this talk, is what have we done to prepare for all these machines coming on so quickly. So back in about 2013, this was a little bit before I got involved with the project, the code was over 20 years old at the time. It had been developed in the classic HPC software mode where add new feature, add new feature, add new feature, over and over in whatever way you can, as quickly as you can. And of course, operating in that mode for 20 years, you accumulate a lot of technical debt. And faced with all that technical debt, and faced with all the new kinds of machines that were coming in, you had nobody that, hardly anybody who really understood the code flow or the data flow. It had gotten so convoluted over time. It was difficult to maintain the code. It was difficult to add new features. It was difficult to train new developers. We had, just due to kind of the timing and the demographics, we had a bunch of older people at the time who were about to retire. We had new staff coming on to take over maintaining the code that they'd written, and it was really challenging for them to understand, wait a minute, what the heck does this thing do? So we had that challenge. And then we also, as I mentioned before, had new architectures coming in that were going to kind of stretch the capabilities that we had to deal with in terms of architecture and optimization. So all these things together made the project management realize that we couldn't keep going the way that we had been going. Something needed to change. So we set off on a modernization effort. The first step in the effort was refactoring the code. And if you see the graph on the left here, which we affectionately call the hairball graph, that is a real honest-to-goodness dependency graph of what the code looked like when we started the process. And as I said, that made it really difficult to understand, what was going on, how the code flow was working, how much of anything worked. You had a setup where basically any file could go and grab data from any other file, and that just made it basically impossible to reason about. So the first step in our modernization effort was to take about a 15-month effort and undergo a major code refactor in place. So not stopping development or anything like this, but as users were using the code day to day, we were also doing this refactoring under the hood. Somebody likened it to rebuilding the engine of the jet airplane while the jet is in the air. And we had several people working on this. We were able to separate out into the code into much more well-defined, more isolated packages. And we ended up, at the end of the process, with a much nicer looking graph that you could actually understand and reason about. And it had the additional benefit that once you could reason about it, that enabled you to then start making other changes on a per package basis. You could just pick out one or two of these packages and start making changes to them and have some understanding of how they connected with the others. So we were able to introduce things like unit testing, better documentation, do code cleanup, performance optimizations, do some improved physics, and start introducing support for advanced architectures like GPUs, all on a per package basis because we had done this refactoring. Another step that we did early on was improving our test system. There was, when this process started, we have sort of a test system. It was not really well maintained, but one of the first things we did early on was to, as a project, commit to getting the nightly tests passing and keeping them passing as a safety net to make sure we weren't breaking anything while we refactored. So we would have the nightly report that went out, and the goal was to have the wall of green where all the tests were passing every night. And that gave us a good basis for doing the refactoring. As I mentioned on the last slide, we were able to introduce unit tests as we went along. As we started to create these packages, we were able to create unit tests for a lot of packages to go alongside the integrated tests that we already had. And later on in the process, we were able to augment that with CI that was done through GitLab CI as part of our merge request process. Thank you. So we, having done those steps, the next thing to do, one of the big things we were looking to do was to introduce GPU support into the code. We tried doing this a few different ways. Our first attempt was to, since the code was in Fortran, try to build something Cocos-like, if you're familiar with Cocos. It's in C++, makes heavy use of templates. We attempted to do something like that in Fortran so that we could apply it to our code. The heroic effort was made by some people who really thought hard about it, but they ran up against the obstacles that Fortran doesn't have things like templates and lambdas that Cocos, of course, is heavily dependent on. They got a system kind of working, but it became, as they implemented it more and more, it became too difficult to maintain and too difficult to expand, and eventually the effort had to be dropped. So a second attempt was made, also working in Fortran, to do the OpenMP offloading that was in that language. That had the advantage, excuse me, that had the advantage that it was compatible with Fortran. Had the disadvantage, we discovered, that the offload implementations of OpenMP that we were relying on were not very mature, especially within Fortran. And we also discovered that the standard did not really have a good way of handling Fortran 2003 derived types, which we made heavy use of in our code. So that made it difficult to pursue that strategy. So we pivoted to a third strategy, and that was to use C++ and Cocos. This did have a little bit of a downside that in order to do it, we had to start porting some of our code to Fortran and C++. And I'll say a bit more about that in the next slide. But as we did that, that had the advantage that Cocos is very flexible, it's well supported. We have good, Los Alamos has good connections with Sandia where that's developed. So we were able to leverage that. We were also able to do this conversion process incrementally. So pick out a small set of routines that would have particularly high value to optimize and do those first without having to convert the entire code. So that has been a successful strategy. One of the key parts of this was being able to bridge between the existing Fortran in our code and the new C++ that we were starting to write. And we were able to leverage, there are Fortran to C and C++ interoperability features in the newer versions of Fortran. Initially in 2003, more was added in 2018. Basically what this is allowing, it gives you a C type that allows you to get into the Fortran dope vector, access all the metadata, and understand what a Fortran allocated array looks like, and enables you to manipulate it on the C++ side. And having done that, it enabled us to then build a Cocos views that corresponded to our Fortran arrays and work from there. We were able to develop, using some fun C++ template features and so forth, build a system that would generate Fortran and C++ types from a single description. Early on in the process, we'd had to write two types manually and hope that they stayed in sync with each other, but excuse me, we were eventually able to build a system where this was auto-generated, and that removed a lot of the risk. And the end result of all this is that we now have, from our main Fortran code that we've had all along, we're now able to call into C++ routines that run under Cocos and run on their GPU backend. And so we're able to finally get our GPU functionality from X-Rage. Now, in the process of doing all this, we've also been adopting some new tools. We've picked up the Confluence Wiki to gather our documentation. That is a great improvement over the, oh, somebody has an email about this. Let me forward it to you. Confluence is a much nicer system than that. We've moved to GitLab to do our version control and our CI. That took some getting used to, but we've been able to pick it up. We've moved to SPAC. We've moved to CMake. That was a huge effort. I've given entire talks about that, which you can say more about that offline if you want to hear it. And then another big piece that has surrounded all this is changing the culture of how we approach software. We've had physicists and computer scientists who have different priorities. They talk in different terms. But we've been able to at least start to move past that, to learn to understand each other's concerns. We've brought a CS lead onto the project, more CS support alongside the physicists on the project, and more time for code cleanup. And so in summary, we've made a lot of progress through all this, and this is just a whirlwind tour. But because of it, we're now better prepared to move to all these new, unusual platforms coming in, including whatever strange thing they throw at us in the future. So, thank you.
Oh, I was going to say, should we save the questions for the panel?
How are we going to?
That's what. Okay. I do, because I haven't got mine up. Cool. So, top question is, with 20 plus years of technical debt, was it tempting to do a complete re-implementation rather than trying to refactor the existing code base?
Yes, that was in fact a big discussion when we started this process. We considered writing an entire new code base. The drawback to that is that with 20 plus years of development, you have a code that people have been using, have been testing against all sorts of different use cases. There's been a lot of formal and informal V&V that goes into the code. And if we wrote a new code, writing the new code, okay, that might not be too big of an effort, but what would be a huge effort on top of that is then replicating all of the V&V that had already been done and getting not just ourselves but our users to believe that the new code actually did all the same things that the old code did, which was a huge proposition, which is why we decided to do the in-place refactor instead.
Shall we thank Charles again, please? Yeah.
Doesn't allow me to share. Does anyone know what's going on? I cannot share. I'm in the thing, but it says I can't share because someone else is sharing. But I tested it just before and it worked.
Is it because someone's already shared on that?
Yeah, but
so I think
oh, just here, just click this.
Yeah, stop that share then.
Oh, okay, great.
We can't find the mouse.
That's all right. There he goes. So our next speaker is Tom Meltzer to talk about the MDB debugger.
That's right, I've got this. Okay. Yeah, is that working? Yeah, sick. All right, yeah, thanks for having me today to talk about this. So I really love tooling for kind of software development. So I'm all about kind of profilers, debuggers, and I work a lot with MPI code. And so today's talk is going to be focused on how do we work in a nicer way with MPI applications. So yeah, I'm going to talk a bit about the debuggers, but I'll go through it quickly because I would like to get time for a little mini live demo. And then I'll talk about my attempt at a solution to the problem. So for anyone who's not familiar with a debugger, it's a program that is used to test or debug another target program. And the target program is the one that we want to debug, and that's going to be run in a controlled environment, and it will allow the user to inspect resources, maybe to interrupt the program flow, and also they can modify code execution, which is something I'll talk about later and something you can't get with your classic print statements. So you might be thinking at this point, I'm just going to switch off because, can't I just use printf, print, cout, whatever you like? And I'll be honest, maybe it's not always such a bad idea. It can be a valid idea if your code can't run without optimizations. Sometimes you might have a code that takes a very long time to get to a certain point. When you add debug symbols and you build in debug mode, your code will just take a bit longer to run, and maybe that won't be possible. However, the downsides of printf and any other kind of printing statement is it requires recompiling your code. You could actually introduce new bugs. Maybe you've forgotten your semicolon, or you've added some extra brackets, or you've done something, and you could have changed the flow of the code. And then you get to a point where you say, oh, actually, yeah, that's great. I've now run this, and I've printed that, but I actually just also want to see what this variable is. Well, you have to go back through the loop, recompile again, add a new print statement. And my most favorite feature of debugging is you can actually interactively alter the runtime. So if you're coming up to some kind of break in your code where there's an if statement, it says if this, do that, or do this. With a debugger, you can set your variable, from true to false or false to true, and you can actually change the flow of the program, which is something you can't do without the debugger. So here's the current kind of landscape for MPI debuggers, at least as I see it in kind of my personal experience. So I've sort of got a money and features and support graph up there. And I don't know if this is this little thing, laser. Yes, so we have our features and support, we have our money axis, and over here there's two kind of sort of main proprietary versions available. There's a Linaro DDT and a MPI debugger called TotalView. I actually can't tell you how much they cost because it doesn't tell me on their website, and that's a problem for me. I also can't afford the license, so I can't test it out on my own laptop, and sometimes they even offer kind of free academic licenses, maybe. But if I move to a different HPC system and they can't afford the license, then I have to learn a new tool. With features and support, though, we've got some free ones. Intel have their own distribution of GDB that is MPI aware. However, it does break a crucial feature for debuggers, which is the interrupt. So you should be able to press Control-C, interrupt the code execution, and kind of see where you've landed. But if you do that in Intel GDB, it just quits the debugger, which is a bit annoying. And then there's some free versions which I don't have time to discuss, but please check them out if you're interested. These are clickable links, and the slides will be shared. So now I'm going to introduce kind of my solution, pending logo. This is my ambition, right? It's nice, isn't it? It's on the free axis, brilliant, free and open source. Yeah, this is the ambition. Maybe we're currently kind of in between. So we'll see, because there'll be a live demo, and you can make your own minds up. So I've got some key features that I'd like to kind of summarize and why I built this tool. So it's terminal-based. I'm an RSE. I work on loads of different HPC systems around the world, and I like to be able to debug my code where it exists in its environment. So I can connect to any of the kind of HPC machines I use. I can use the libraries that they're using. Sometimes, if you're debugging, it could be a problem with the build kind of system, the libraries, the versions that you specifically have. And when you build it locally, it might all run and say, oh, it runs fine on my machine. So I like being able to debug locally. It can use multiple backends, so I can use GDB or LLDB. That's an option you can see in the documentation. It uses Python's asyncio library under the hood. That's important because it doesn't just run on I don't run 1,000 threads for each debug process. It's an asynchronous process that sleeps when it's not doing anything, and so it won't melt your CPU if you're running with a lot of threads. And yeah, there's some holistics. You can use some plotting, which I'll hopefully show you. Key point, it's scriptable. If anyone's used GDB in the room, you can write a little script. You can have your debug session automated. And this is very good for MPI codes, because MPI codes typically, once you've gone past the initialization step, MPI init, you can't go back and rerun the program without fully exiting. So it's nice that you can kind of script it and say, run up to this point, chuck me in, maybe print some variables along the way. That can be very handy. And it's free and open source, so if you don't like some feature or you want to add a new feature, you can do that. And it's now pip installable as of yesterday evening. I'm trying to make a SPAC package for it as well, so that's a SPAC recipe, and so that's why I've made it pip installable. So we're going to jump into a little live demo, just because I think it speaks sort of 1,000 words or more. I'm not expecting everyone to kind of read absolutely everything. I just want to say I've got a sample Fortran program. Okay, it's called Simple MPI Example, and it just does some initialization, and then maybe see, so it does some initialization. It's going to set a variable and print some stuff, and then it's going to kind of quit. So that's going to be what we're running. I'm using a thing called tmux, which again I don't really have time to explain, unfortunately, but it is cool, and I do recommend you check it out. So this is how we're going to launch the debugger. We're going to say mdb launch. This kind of -n is familiar for MPI programs. So you're going to say I want to run 8 processes. And then the target program is the program we want to debug. So this is going to be simple MPI. But before I do that, I think I need to build it. Let me just make sure I did. So I'm going to do ls. I'm going to make, I've got OpenMPI, I've got a distribution of OpenMPI installed. That's a dependency for MPI programs. So, well, you need an MPI implementation. So we've got our binary, simplempi.exe, and we're going to run the launch command, if I can switch windows. So this is the command we're going to run. I'm going to hit enter. It's going to launch 8 processes. Currently, I've got some debugging information printing, so I can see what commands it's actually running. It's using the GDB backend. But now, for the rest of the talk, we're just going to focus on how do we get into that debug session. So I'm going to run mdb attach. If you're not sure what the commands are, you can run help, and you can get kind of help information all along the way. Similarly, for attach, you can see kind of what the options are. I'll also point out you can do something like man mdb. There's man pages. There's instructions in the read the docs that show you how to kind of install these if you want them in your terminal, and there's examples and things like that. So we're going to do mdb attach. And now that's it. We're into the session. So I could do something like command info proc, and this is going to run this command on every single process. We've got 8 of them, and so they're nicely sorted in order from 0 to 7, and they'll always be in order, which is helpful if you're looking for specific processes. You could also run something on a specific process, like I could do 3, 5 to 7, so it's like kind of comma and hyphen separated, and we could do that. We could see where we are in the code, so we could do list, and that's going to run it on 5, 6, 7, okay? But what I'm going to do is I'm going to do command and next. And this is just going to start stepping through the code. Due to the Fortran and GDB kind of interface, it sometimes jumps around. There's maybe some extra optimization I don't want, but it's jumping around a bit. But then we're going to go through the MPI initialization on all the processes. Now, this is the cool thing I want to show you. So I've got this holistic called plot, and if I've got a variable, I'm going to plot it. Now, it's not been set yet, so it's all going to be zeros. It's kind of boring. But if I do the next line, and I step, and then I do a plot, you get a nice little terminal plot, and you can see kind of the values and the mean, the min, the max. This can be really good if you've got like 1,000 processes and you want to know, they should all be a constant maybe. You can quickly find that out. Obviously, if you've got 1,000 processes, this term graph is going to be very long. There's an option for matplotlib backend, so it can plot it in a GUI, which may or may not be what you want, depending on if you've got X forwarding or something like that. But that's why there's a terminal-based graph as well. And you also don't have to debug every process. Again, it's in the documentation I don't have time to show now. But you can say selectively debug ranks 1 and 1024, whatever. You don't have to do all of them. That's going to be the end of that. So then I also just wanted to show, let's create this in a sec. So I have a GitHub page, which you can have a look at. There's a README. Currently, the tests do fail on the CI because there's a problem with the virtual machine and networking, which I need to figure out. If anyone has any ideas on that, they can read the issue and maybe help contribute. I also wanted to point out that I have a quick start guide in the Read the Docs. It's linked from the README, and you can also search MDB Read the Docs. This quick start guide goes through an example program, a bit like I've showed today, and it talks about how to run the code, how to use the debugger, what sort of output to expect, and it's like a nice kind of contained example. And unfortunately, my screen share thing's in the way. There's an installation. It talks about how to install it. You can now pip install it, and soon there'll be a SPAC recipe coming soon. And it's now, yeah, this is the pip page. So I'm going to go back to my talk and just finish up the last minute. Is it one minute left? Yeah. So here's an honorable mention of some other tools. I won't go through them, but again, the slides will be provided, so please take a look. This isn't the only option, it's just my solution. And then I'd just like to say thanks. So Fergus contributed a lot to this project. He helped me kind of do a lot of stuff with the asynchronous backend. And yeah, there's the GitHub link and the reader docs. Thanks very much.
Thanks, Tom. That's amazing work. I'm a shameful user of print statements myself, so I'm going to have to give it a go. So we've got time for a couple of questions, actually. We've got one which was, how much time do you estimate it's taken you to get this far? And have you had any financial support from your organization or anyone else at all?
I haven't asked for financial support, but I haven't had any. So it's all been spare time. It took, I reckon, about, it's hard to say in terms of what you mean, but like 6 months of my spare time, but sometimes I spent I think I spent Christmas doing it one year. It's a pet project. I'm really passionate about it, and so I got some spare time. I spent probably like a week solidly, and then it's been like days here and there, and about 6 months of those days here and there.
Cool. Another question, can MDB attach to a running MPI application with debug symbols, or must the application be launched via MDB at the moment?
It currently needs to be launched. There's hacky ways around it, but it's just easier to launch it. Yeah. But yeah, you don't have to, because the program would need debug symbols anyway, there's not really a benefit of attaching, in some sense, to the running program. Yeah, but it's possible, but not with, I'd have to make changes to the code.
Cool. Okay, let's thank Tom again. So just a quick update to the running order. Because we took a bit of time to get started with technical difficulties, we're going to move the lightning talks for the HPC providers to the next session, and then just take 10 minutes off of the wrap-up at the end. So hopefully we shouldn't lose any of the good content. And I'm passing over to, is Nick to do the panel, or is it yourself?
At least I think it's me. I hope it's me. Otherwise, somebody's going to be really disappointed. In fact, everybody's disappointed because it's me. But there you go. So can I invite our panel members? So that's our two speakers, plus Nick and Mirren, to come down and grab a seat. There is a microphone for you to share. There is water if you need it as well. And so we're going to have our panel. And so if people have questions about anything HPC related, I'd say probably more the sort of technical side of hardware or machines or compilers or software or things like that for this panel. We've got another mini panel in the second session, which is going to cover more the sort of training community aspects. So we do have some prepared questions that we haven't told the panel in advance, of course, because we're very kind like that. Or please post questions to the Canopy, and I'll try and favor the ones that are in Canopy as well. So apologies if I look like I'm fiddling my phone. I'm trying to look at questions and see what they are. So we've still got lots of questions about NDB actually in Canopy. So I'm not going to go for them at the moment. I'll wait till they've been cleared out, hopefully by the organisers. Pardon? They're cleared? Okay, it's just taking a while for it to update here. Perfect. So get your questions in. But I'll start out with one of our prepared questions. So I guess one of the things we'd sort of prepared for before the session, which we did a lot of prep before the change in government, was talk about exascale a bit, because there was funding for a UK exascale system. But I think this question is still relevant, even though the UK government have paused the exascale project because they've got no money, essentially, I think. But how many codes are there out there, do we think, that can take advantage, particularly Charles was talking about this, can take advantage of actually the capabilities of an exascale system? So how well covered are we in the community to talk about that? So I'll give you the mic. Who's willing to go first on this one? And Nick, I know, has been involved in Excalibur as well.
I have to go first. I mean, I think very few. I suppose maybe I would rephrase the question: how many codes can actually take advantage of petascale systems? Is maybe a more immediate question. And that's why I was fascinated with your talk in terms of all that stuff over the years that you then look at fixing and moving forwards on. And I guess it's a thing that quite a lot of us have done in the room in terms of had a code many, many years ago designed for a very different era and different type of machine, and then actually having to pull it apart and bring it back together. And one of the things that really struck me about your talk, and I was going to ask the question, and I'll use this opportunity maybe, is I was fascinated by, yes, it's in Fortran, but then having to move away from that to then do the GPU side of things. And it really made me wonder, I mean, I'm a great believer in Fortran, I must admit, but it really made me wonder, you know, do we have to embrace moving away from some of these traditional things that we've had for many years, and actually, for some of us, looking at new technologies and new techniques, which is quite an extreme change. I don't know if you have specific views on that.
Well, I would say that when we started on our process, however many, 10-ish years ago, we, as I said in the talk, we tried a couple of different ways to stay in Fortran that at the time when we tried to do them weren't viable, and which is why we ended up doing our strategy of moving to C++. That was 8 to 10 years ago. It may be that the landscape is different now. I can't speak to that. But it's not necessarily, the choices today are not necessarily the same choices and trade-offs that we had when we did our process.
I guess I have a follow-up to that. Maybe the panel might want to. I have a follow-up to that the panel might. The rest of the panel might have opinions on, which is so you know you in your talk you talked about how your code you kind of added your interoperability to C++ to Cocos, and there are lots of Fortran HPC codes, large codes that would require lots of resources to do that, to either rewrite in C++ or add the interoperability with C++. So my question is, why isn't there a Fortran API to Cocos or something like that? That you had to develop yourself. There's a big market for it, and I your point about these methods you tried, OpenMP and this kind of thing, not being mature. I still hear that today. It's still much less mature than C++. So why isn't there either Cocos or an alternative library? Why isn't there a Fortran API? Is that possible? Should we do that? I don't know if anyone else has opinions.
So I guess one question has been asked by Q&A, which is irrelevant here, which might help expand this. So the question is, loved Fortran codes are increasingly leaning on mixed language solutions. So this is sort of the way you went, I think. Is this building up a big problem for the inevitable need to move away from Fortran at the end? Which is a bit of that's quite a strong statement in itself. For technical and human reasons. And I guess one thing that occurred to me as well when you were talking about your project is that almost felt like the people who were working on this project had to become expert Fortran and C++ programmers, which sounds like quite a challenge, because they're quite different mindsets, I think. So any comments on this mixedness and what it means for skills for RSEs and what we should invest in?
I guess on the training side, because this has come up already in this conference and many before, but I think the reality is, we're just going to have to get used to this idea of mixed languages. I don't think, there are languages that try and sell certain ideas, and Julia's done quite a lot and kind of been built with some of that stuff in mind to kind of target these accelerators, IPUs, XPUs, GPUs, but I'm not necessarily convinced there's always going to be, when you pick a language for a project, it used to be, you think, oh, if I'm doing a web app, it's going to be something, it's not going to be Fortran, and if I want to do my analysis, for my plots or whatever, possibly going to be Python or something like that, and stats is going to be in R or whatever. Like there's kind of go-to places for different things. But as you get more kind of multi-domain and mixed expertise, or your code kind of gets necessarily more complex, I think there's parts of it that we're going to have to just say, like, look, this thing is optimally best written in this way with this language, because even the languages are built around different paradigms as well. And like Fortran, the thing I love about it, because I think we've probably got quite a biased panel up here, but Fortran, like arrays, multi-dimensional arrays are like a first-class citizen. They were there from the start, and anyone trying to do multi-dim stuff, like I just can't imagine wanting to do that in C++ or something where it's not part of the language.
Well, I guess each library does it a different way almost, doesn't it? So, well, although, you know, C++ 26 maybe.
So there is a follow-on question here which sort of carries on this. You know, one of the problems, I guess, it says here, you know, C++ is a better technology than Fortran, which is, I guess is sort of what we're just discussing a bit, and people seem to say it's different, but you know, does it just have better vendor support? And actually, this is a key thing for Fortran, a key problem for Fortran, is, you know, we rely on the vendors providing support for Fortran compilers, and that feels like a risk at the moment.
That's a risk that's actually being mitigated. I know Los Alamos and some other places are heavily invested in getting the Flang compiler working, the Fortran equivalent of Clang for C++, to exactly avoid the kind of thing you're talking about, to have something that we are not dependent on vendors to maintain for us. So that's still a little ways off, but it's coming closer.
Yeah, maybe this is an unpopular opinion, but I'll say it. I think, you know, we're talking a lot about the programming language. As we're moving to more complicated machines and we've got multi-vendor GPUs, actually, it seems logical to me to take a lot of the responsibility away from the programmer. And Flang's actually a really interesting example of this, because Flang, I mean, it's not fully integrated, but it's got a lot of the MLIR toolkit behind it. And that is invested very heavily by the machine learning community. So, you know, you can imagine a situation where we're moving more towards putting more emphasis on the compiler. I'd say it's a dangerous thing to say because we've tried this a lot previously and it's always failed. But, you know, there is a lot of investment going on the machine learning side and around the compilers. So actually, can we piggyback, and maybe things like Flang give us an opportunity to share some of this more? And that's personally why I think that's a very exciting thing going on for us. Because we shouldn't have to worry about this at that lower level that we do at the moment.
I would just add to that, it's not just machine learning, but the whole LLVM ecosystem in general. Having Fortran be able to leverage that is going to be huge.
Yeah, just kind of one thing, because I didn't get a chance to talk about the petascale question. Some of this links to that, and it's nice if we can get things, you know, take away the mundane from the user. They don't have to worry about absolutely everything to get performance. But we are on a HPC panel, and I think ultimately where I see HPC as always needing that kind of, if you want to squeeze that extra bit of juice out, you're going to need to step away from the, oh, I can just trust the compiler or just trust this to do that. And one of the things I heard in a talk recently, it was I think C++Con, is that essentially the top numbers for kind of new CPUs are improving. So like, you know, bandwidth, memory bandwidth's improving, max clock speed, number of cores. But actually, at the cost of the penalties. So like for kind of NUMA hardware, if you're not accessing local memory, in relative and absolute terms, things like latency or other bandwidth, like you're not going to get that max bandwidth. So it's kind of, we've fallen into our own trap where it's like, oh yeah, we look at the top number, it's like this many flops, whatever. Actually, you're never going to see that. And when you talk about how can codes, are any codes kind of exascale ready, I'm strongly concerned from that side that they're not, because we're going to need to do more and more custom things, you know, special compiler options that are undocumented and one person at Intel knows or something, you know. And it's going to be, if you're not working with NVIDIA, you know, programmers directly, you're going to miss that flag, you're going to miss this thing, and you're not going to see that performance.
I mean, I think this goes back to, you know, as we all know, hardware is getting much more complicated, much more heterogeneous, and I think, you know, we can't rely on individual codes, individual things to implement all these, you know, all these different performance optimizations that are specific to hardware. I think abstraction layers like Cocos or Sickle or other things like that are really important, and I think there will be a move to more codes using them.
Okay. Right, so this seems to have turned into the Fortran panel a bit, but so I'm going to do one more Fortran question because it's the highest rated question on the chat, and then we're going to step away from Fortran. Nobody's going to say the F word again in this panel. So, so Jack says, why are we not getting adoption of the Fortran Package Manager, FPM? Surely this is the ideal solution for sharing Fortran solutions. And I must admit, I'm not particularly okay with FPM. Has anybody used it or got any comment?
I have heard of it. I have heard of it. That's the extent of my knowledge.
I mean, my impression, I've been to a talk on it, looked at it myself. I haven't tried it very much, but my impression is that it's still somewhat immature. But I think projects are starting to adopt it. I'm starting to see more and more projects use it. I think it'll take some time, but maybe we'll see. I think it could still pick up.
Yeah, I think we talked on Monday, there was a breakout, Dave, like the Fortran, back to the Fortran, and this was raised there, and it's like, I think there's a lot of new projects that have been started in the last sort of 5 or so years, but then some of them very quickly die, and I think there's a lot of fear for people to go like, why do we invest in FPM or F standard lib, or, they're great projects, but I think people like, you've got people that have been doing Fortran for 30 odd years, and then they're like, oh, I don't, this is just a blip, it's gonna disappear tomorrow, So I think it's the maturity, and people will have a fear, to try that new thing.
So I have a thing to add to that. I was talking to someone at the Batch of the Fortran workshop on Monday, and they were from the Met Office, and they, Met Office are one of the largest users. They have lots of big Fortran codes, and they have lots of users. But they were saying that they can't rely on a lot of these packages because they're just far too immature, so they end up making in-house solutions that they know they can support. So maybe there needs to be more, for large organizations that use these, like the Met Office, they need to more kind of community codes like FPM. If they invested their resources into using FPM, then I think there would be more community buy-in to that.
I think you've hit the nail on the head with the maturity side of things. I mean, a related question is why don't we use domain-specific languages more? And there's 1,000,001 of them out there, but the danger, of course, is it going to be maintained in 5 years' time? And at least going to the lowest common denominator, you're still going to have it, and you've got that flexibility. So I think these sort of things, often do go down to that level, that question.
Okay. So I'm going to move on from Fortran. So there's a question from Mike saying, given how difficult it's been to get hold of NVIDIA GPUs, has the panel got any experiences they'd like to discuss porting CUDA-enabled codes onto AMD GPUs, which are more available? And I guess this is the sort of, if you're AMD in particular, I guess, like to talk about them as if they're entirely equivalent, right? But they are quite different technologies in some ways and have different maturities of the software stack. So, if anybody got any practical experience of using AMD GPUs or thoughts about it?
Well, our practical experience, we have been running on AMD GPUs, and this is with the Cocos with the HIP backend. So we don't have to do any translation. The Cocos team has done it for us. Although there are subtleties, there are details that have to be worked out, but our code looks largely the same because of that. There are also supposed to be more mechanical translators from CUDA to HIP. I have heard some projects have good experience with those. I don't have the direct experience to speak to it any more than that.
I'm in a similar situation in that I use a code that's built on AMRX or AMREX, which is an ECP project, which has a CUDA backend and also has a HIP backend for targeting AMD GPUs, so I don't have to worry too much for that code. I also work on another code that is built on OpenACC support on AMD GPUs, so there's not really any vendor support. I think there's some kind of very immature support in GCC, but I'm not convinced it's very performant. Yeah, I don't really know what I'm going to do with that code running on AMD. Do you
have time? Yeah. So just a thing to add a data point. Someone said earlier about kind of the OpenMP support. Well, yeah, in your talk earlier, you talked about OpenMP support not being mature, as developed. And this is exactly the problem I had. Is I had a code that was OpenMP, and I wrote it for that promise of like, yeah, it's portable, and actually. I think I might have had something like a derived type, and it works with NVIDIA's NV Fortran. And then when I tried to use the G Fortran and even AMD, they had, I think, some kind of their own compiler. I can't remember what it's called now. But I tried both of them and it didn't work because it didn't have that support. And so it's like the OpenMP standard's amazing. Implementation into compilers is not there for Fortran.
And this is this is back a bit to the vendor support for various compilers, right?
Yeah, but I mean, to be fair to AMD, I did this 3 years ago, so I haven't tried it since. But it did put me off, and now I think like Cocos and things like that are the way. Adaptive CPP, one API, SQL stuff are the way to go.
But they're all C++ at the moment.
They are, yeah, that sucks.
Yeah, I mean, there is a particular challenge around the Intel hardware, I think, because it's very SQL-based, and Fortran and SQL aren't really things together so far. I think, Miran, you might know more than that.
So, I mean, yeah, I mean, if you have a Fortran code and you want to do the vendor-supported way on Intel GPUs or Intel accelerators, it's the only way they offer is OpenMP, unless you want to interface to C++ and then use, you know, either SQL or Cocos or something else.
Sorry, I realised I just broke my own rule and said the F word. Okay. So I think we've got time for one more question, which is a more general question. So yes, Yassel is asking, you know, what are some key things to consider when porting a big application from one HPC system to another? I think I'd try and distill it down to, you know, what is your most important thing, and thing can mean anything from technical to organizational thing when porting, when you suddenly get access to a new system, new hardware, and you've got a well-used application you want to port. What are you thinking about first?
So I'm going to use this to say something I thought before, but I think it is sort of pertinent. I think the key thing to bear in mind are the users and who's going to be maintaining this in the future. Because sometimes, you know, excellence is the enemy of good enough. And what I mean by that is I can remember a number of years ago the code, we spent a lot of time tuning it and optimizing it. There was quite a cost in making the code quite complicated. We handed it over to the scientists and they said, you know, actually we would take a 10 or 20% performance hit if it was more maintainable. You know, sometimes we do fall into this trap of we are pushing it for the Ferrari of performance, you know, and that's fine, you know, but, you know, we've got to consider who's going to be maintaining this in the future, and actually, is this going to be causing a problem later down the line? If maybe we could pull back a little bit, but then look at these other dimensions of what's important here.
I would say the number one thing that is needed is a robust testing system. As one of my previous project managers used to say, if you get the answer faster, but it's wrong, what good does that do you? So having the robust test system where you can go in and make all these changes and know that you have not broken anything is huge.
I was going to say, I guess from the beginning, you know, from a developer point of view, it's kind of important to keep things as portable as possible, so not rely on things that are specific to one HPC system. You know, that might be the only place where that code is used at the moment, but going forward, you know, the HPC system will be end of life at some point. It'll be replaced. You might have to use the code somewhere else. So, I mean, and also kind of retrofitting codes that have already been kind of targeting specific. They've already been written in a way that targets very specifically one system, kind of adding in, making them more portable. I think there's kind of a great benefit to doing that.
I'm so glad I'm going last because they've said all the kind of good stuff. I get to say some kind of more miscellaneous things. One is just to reply though to what Nick was saying, which is, yeah, if you want the fastest performance, you'd probably write assembly. I've never written assembly in my life. I don't know how to read it. It would be completely unmaintainable. But that's if you want, you know, really performance. So I agree there's definitely a balance between getting performance and making it maintainable. But I now get to talk about my other favorite thing, which I'm normally banned from talking about, which is SPAC. So from a practical point of view, honestly, if you're going to be moving different platforms, okay, it may not be the most, you know, you want to use the system-provided libraries because they will be performant. But if you just want to quickly test something and make sure it's running, like having a SPAC recipe and being able to, like, you know, SPAC install, you can switch all the different kind of modules and try different versions of things very easily. Other build systems exist, but yeah, it's just a recommendation. It's made my life, you know, taking different academic codes and running them in different systems. It's the first thing I'll do. I set up SPAC and then I can test it out.
Okay, thank you all very much. I think we're just about at the end of the session, so I don't think we really have time to go into it. It wouldn't be fair to go in for another question. We've got a few minutes left. So first of all, can we thank Nick, Charles, Miran, and Tom very much for their insights. Hello, everybody, and welcome back for the second half of the HPC RSE BOF. We've now got the lightning talks from service providers. So can the people who are giving these lightning talks, I think we might have one online person as well, but for the people who are in person, could you come and sort of line yourself up in the traditional I know, queue of shame, or whatever you want to call it, down here that is traditional for lightning talks, and we'll go through them one by one, and we'll pass over the microphone. You've got essentially 2 minutes each, and we'll see how quickly we go. So, hopefully, just a minute. Ooh, it says Dirac, but it's not moving. Where are the slides? No, but the slides were all in one presentation that we had. So you just have to click that way. Sorry? Left and right? Yeah, it should be left and right. Oh, so this is Alistair, your slide looks like it's just bugged out. So what should... Do you want to go to the back of the line? We'll do everybody else first.
I can download it and open it via PowerPoint. It might.
Yeah, it'll probably work. Yeah, exactly. So we'll do that. We'll fit you in at the end if that's okay. Yeah. Cool. Right. So that means? Oh, it's me. So I'm first. Talk about Archer 2. So Archer 2, for those most people probably know, UK National Supercomputing Service based at the University of Edinburgh, HPCRSE. I only really want to say one thing about it. And that was to highlight there's this GPU ECSE call at the moment where you could apply for either funding to fund your own RSE effort, or if you want RSE effort from people within the team at EPCC, you can apply for funding for them as well. But it supports both sorts of models, this ECSE thing. So it's to work on research software development, targeting an accelerated architecture. It could be any research remit, any accelerated architecture that you're interested in. And the closing date is 17th of September, so you have to be quick. A few people have asked if there are going to be more calls. In the current tranche of funding, no, there are not. UK are keen to continue this in the future, but they haven't got any guaranteed funds. So this call is hopefully not the last opportunity, but is the only confirmed opportunity left, if that makes sense. Please do come, do think about applying. If you want to know a bit more, come to the EPCC booth and chat in this time that's left of this conference, or drop us a line about support desk. That's all I wanted to say about Archer 2, really. But if you want to ask other questions about Archer 2, about how you get access, it's quite easy for anybody to get access, so just come and ask, or look at the Archer 2 website. Who's next? Nick?
So hello, my name's Nick. I'm from EPCC, and I am representing the Excalibur program. So we've heard a lot about exascale supercomputers. Obviously, it's very exciting. We are moving further into the exascale era, but it's all for naught if we don't have the software that runs on them. So that's why we are absolutely key, I think, to this stuff that's going on. And so for the past 5 years, we've had this program in the UK that's been funding people and software moving in towards exascale. Quite a lot of people are probably involved in this to some extent, but maybe you don't have the big picture because it's a big program. And so what this has been driving is looking at a couple of key use cases as the foundations, so weather modeling and climate modeling, and also fusion science, but then adding a whole load of things in this that are contributed by the community, other use cases and other requirements. And then coupling that with some emerging things like biology, like agent-based modeling, things that might not be yet making full use of these machines, but could in the future. And then looking across these to see, well, what are the cross-cutting challenges that we can extract out? Things like compilers, domain-specific languages, parallel in time, task-based models, uncertainty quantification, all of that, and then trying to feed this back to those people. And then, coming towards the end of this, hardware enabling software, looking at what the future hardware and architectures might be in the next 5 to 10 years, and again, making sure we're ready for that. And then lastly, knowledge exchange and reaching out to the community and the wider world. So that's what we're about. Very happy to talk more about this. And just a plug to finish on, we have a workshop mid to late October, free to attend and register. So if you'd like to go to that, please have a look at the website or ask me for more details.
Okay, so I'm going to have to try downloading this because it's not working anymore. Yep. Nope. Nope, that was the last one then. So, just a minute. Okay, so we have a presentation from Jasmine. I think it's somebody online is doing the Jasmine presentation.
Hello, can you hear and see me?
Yes, we can hear you, Dan.
Okay, perfect. All right. Can you see the slides? Because I can't see it from here.
Oh, is the slides not being shared properly? Did I stop that happening?
I think there are two screens that are being shared. And so up at the top it said Richard's screen or Samantha's screen. So if you go onto Richard's screen, you can see the slide.
Okay. Perfect. That's all right. Okay. All right. Hello, everyone. I'm Danny Lloyd. I'm a graduate at STFC on the Jasmine team. So Jasmine is a bespoke data-intensive environmental science facility. It's got over 2,000 users who conduct collaborative research on topics ranging from climate change and oceanography to air pollution and earthquake deformation. So we've got the CEDAR archive, which is about 25 petabytes. It's a key part of NERC's environmental science data service. It's available throughout Jasmine, providing the concept of bringing compute to the data, enabling interdisciplinary data analysis at scale. Users can develop code interactively on our scientific analysis servers or our Jupyter Notebook service, and then they can scale up onto the Slurm cluster, tens of thousands of CPU cores and GPU nodes. Alternatively, they can roll their own compute in the Jasmine Community Cloud. We maintain a collection of packages tailored to our Earth observation and climate science community called JazPy. And we've got group workspaces which provide high-performance shared storage for projects. They can then move data in and out of Jasmine using high-performance data transfer services. And this is all supported by a Jasmine team, providing help desk, documentation, training, and support to help users get the most out of the platform. The Jasmine service is operated on behalf of NERC, two halves of the team within STFC. The CEDAR team develops and operates the services, while Scientific Computing Department implements and operates the hardware. And together we support the wider NERC community, including NCAS, the Met Office, NCEO, plus NERC-related researchers in universities and institutions in the UK and abroad. Yeah, so that's it.
Thank you very much, Danny. Right, let's try and get Alistair's slide up. Are you sure? Okay, I'll give you a Dirac logo there. You can manage that.
Right, there we are. So Dirac, yeah. So you have to use your imagination for this one. What is Dirac? It's the HPC facility that's funded by STFC, the Research Council. At times, it's the UK's largest provider of academic HPC. Dirac is based at 4 sites. Oh, we actually have a slide here that I can read off. That's even better. Right, based at 4 sites: Cambridge, Durham, Edinburgh, and Leicester. Head office UCL. The science done on the Dirac systems is basically HPC for the STFC theory community. So that's cosmology, astronomy, particle physics, nuclear physics, solar physics, that sort of stuff. It's accessed. If you want access to it, you get that through Dirac Safe. There are annual calls for time. And one of the things we do in Dirac is we do bespoke system design for the different systems at different places. So at Durham, for example, we have a memory-intensive service which concentrates on large memory workloads. Edinburgh, we've got the extreme scaling service, which currently is a large GPU system. Actually turned out to be very good for AI. It wasn't designed for that, but it works very well for that. We have data-intensive systems at Cambridge and at Leicester. We also have a lot of novel hardware provision, whether that's in terms of different types of storage, whether it's GPUs, DPUs, Bluefield, etc., composable systems, all that sort of stuff, ARM, fancy network fabrics, even some quantum computing. We also work quite heavily on net zero, so we have a significant installation of solar panels, funded by Dirac. We do a lot of user energy reporting. We look at code and system optimization. We look at bespoke system design, powering off nodes when they're not in use, and that sort of thing. More importantly, we do a lot of user training. This is 1 minute, I think. Good, yeah.
helps not having slides. We do a lot of user training. It's supported by RSEs, code profiling, code optimization, debugging, code porting, basic HPC stuff, industry placements, hackathons. So if anyone's interested in industry placements and that sort of thing, we can get you on those with Dirac. We do a lot of RSE training as well as user training. RSEs, when they're working on Dirac projects, usually work in pairs, which really helps with pair programming, helps with that technical knowledge gap and so on. Projects, the science projects have a competitive application process to apply for RSE time. And we've had multiple RSE wins within Dirac. So Dirac RSEs were involved with benchmarking for new systems, Dirac 3 systems. We've had a lot of code speed-ups, significant speed-ups, GPU ports, and so on. So there we are, that's Dirac.
So, sorry, we'll just get the next one up. See if that works. Nope. Yes, maybe. Fine. Are you okay to go like that? Is that good? Yeah, it's opened in the documents.
It's on screen, right? Close enough.
Okay, go with that.
It'll do. It's my way of working anyway. So hi, I'm Arjen Weers. I'm a senior RSE in Cambridge. So I just want to tell you a bit about what's been happening the last year at the Cambridge facility. So we host CSD3, one of the national HPC facilities here. So we've got a couple of clusters covered by CS3. There is Cumulus, which is mostly our CPU clusters, which we have been expanding with some lovely Sapphire Rapids nodes recently. We're still running Wilkes 3, our A100 GPU cluster. And in the last year, we've brought Dawn online. So if you've seen any of the AIR, the AI resource or Dawn sessions, you've heard more than you ever want to hear about it, so I won't go into it. I'll just say, just want to shout out especially to our, this is our RSE session, but just shout out to our platforms and data center teams for the Herculean effort they put in to get that system online in time, in 3 weeks. So I just want to share a few highlights from last year. So we've been expanding. We've got 16 people in our RSE team now, which is 7 new faces, which is great. And we are still hiring more, so hopefully that will be a bigger number next year. So we deliver our, we have our compute service, but we also serve RSE services. So we've been doing a lot of training. Some highlights, excuse me for the missing indentation, include the ICCS summer school that our colleagues in the Institute of Computing in Climate Science have been delivering, which was excellent. Been doing a bunch of workshops on SYCL or OpenFP offloading to support our Dawn system. And we've been doing a lot of academic collaboration. So Dirac has already been mentioned. There's a very collaboration in the ICCS. We've got medical projects. So we try to, we strive to get our RSE skills out there in the world within Cambridge and the rest of the UK or the world. Help people, use our systems and their systems more efficiently. That's me, I guess.
Right. We've got one more, and then we're on to the talks. Give me a sec. Let's just do the same game. Hopefully it will work as well this time. Or work well enough. Nope, it won't. Yeah, let's go for it. Nope. Did that download? Sorry, what did you say, Ryan? Does anyone know how to make that full screen? that didn't work. Sorry?
Click this button. Click that. There.
This one?
Yep. No, the one next to it. Next to it. The cross, the little cross.
Oh, that one?
It's tiny. And then just click this, whack this up.
That one. Sorry, technology failure. And I think a presenter from EMBL is online as well.
Yeah. Thank you. Yeah, thanks for having me, Ahmed. So yeah, I'm presenting today about high performance computing infrastructure at EMBL. So EMBL, for people who are not familiar with, is a leading global bioinformatics institute. We are based in Wellcome Genome Campus in Hingston near Cambridge. Yeah, it's a non-funded intergovernmental organization. It's non-profit, sorry. So focusing on the HPC infrastructure we have a couple of clusters. The main one is more than 400 nodes. That's about 20,000 cores. It's a heterogeneous cluster, but mainly relying on Intel architecture. So we have Cascade Lakes and we have Ice Lakes. We have big memory nodes with 2 terabytes of memory, and we have GPU nodes, all NVIDIA, mainly A100s, but we have few V100s as well. Our scratch space is about 5 petabytes, and we have a huge archival storage because researchers and bioinformaticians keep and store and analyze their data sets on site. So it's about 400 petabytes. As an HPC team, we manage everything related to this infrastructure, from hardware management to OS upgrades. We don't have a dedicated applications team, so we do application support on best effort basis. We rely on SPAC to build our software stack. And we have moved recently from using LSF to using Slurm. As a team as well, we are involved in consultation, trainings. We have a couple of user trainings per year. And we are interested in green computing. So we have recently implemented the power saving feature from Slurm. So Slurm will power off nodes when they have not been used for a while, and then we'll power them back on when needed. The tools we use mainly for provisioning and management. For provisioning, we use Werewolf 4. Our compute nodes are stateless. We provision them with Rocky 8. We have Check&K for infrastructure monitoring. We rely on other monitoring solutions as well, like NHC for compute health checks. So Slurm will drain a node if it doesn't pass a specific check. And we have some Prometheus exporters and Grafana dashboards to visualize some other metrics as well. For configuration management, we rely on Ansible. So Ansible playbooks will run on the nodes after they are provisioned. We have recently implemented infrastructure HPC portal based on Open on Demand. On that, we have installed more than 10 applications. Was mainly implemented to minimize the overhead of offloading data from our HPC cluster to the user's laptops to do post-processing. So currently now, users can run Jupyter Lab, RStudio Server, VS Code, PyCharm, or many other tools and editors to do the post-processing and visualization on the cluster and close to where the data is stored and where the data is analyzed as well. So Open on Demand is integrated with Slurm. I think many people will be familiar with Open On Demand. It's user-friendly. It has a user-friendly interface, and users can easily access their data in the cluster, do some visualization jobs, and submit jobs easily to Slurm.
Thank you. Can we just thank all the lightning speakers again? Okay. We're moving on now to, I think, the community and training presentations. So Thomas is taking over at this point. So I think
Thank you. So hi everyone, I'm Tuomas Koskela, I'm from UCL, and in this session we're going to have two speakers, and we'll start with Marcus Kiel, who is online. Are you ready to go, Marcus?
I am. Do you want me to share my slides?
Yes,
or?
So I probably need to stop sharing here. I don't need to stop sharing. Oh, okay, I just moved to the other tab. Okay, so can you share your screen, Marcus? Yeah, as a quick introduction, Marcus is a RC in UCL Computer Science, and he's going to talk about profiling. Okay, I'll remind you when it's time to wrap up if you're not doing that by then.
Perfect. Thank you very much.
Go ahead.
All right. So I want to talk to you guys about a tool that I've been creating called PyProfQ. Not necessarily for RSEs, but more for something that you might be able to give to any science users that you have, that you are working with. And what PyProfQ is it's essentially a Python package that can take a bash script that contains queue options, or you can give it queue options in the Python script, and you can define which profilers that PyProfQ is compatible with that you'd like to use on that bash script or within that bash script. What it gives you as an output is two separate bash scripts, one that contains any form of initializations that you need for the profiling or for the plots that will be created by PyProfQ, and the other is a modified work bash script, which is the original work that you had in your bash script, but with the queue options removed and potentially, depending on the profiler, some additional information put into it. Additionally, once you run it on a cluster, the profiling bash script will also have information in it to scrape metrics and potentially plot metrics depending on which profiler you're using. There's a GitHub link there at the bottom if you wish to look at PyProfQ and potentially recommend it or even use it yourself. So how would you use it? It's quite simple. If we say this is the bash script that we have as a user, I doubt anyone's running these kind of bash scripts, but just in case, you see here the slurm options are at the top, obviously, and then you've got the actual commands that are being executed. And in a Python script, what I would do in this case is I would just say, okay, my base directory is this, and I want you to run I want you to create a object that is from the script class. It is going to a queue system that is Slurm. The working directory is listed there. The read queue system is Slurm, so this does also translate. Currently, it's compatible with with Torque and with Slurm. I'm working on expanding what it is compatible with, but the intention is that it can translate. And you can then give any form of queue options. So if you forgot to have them in your script, or if you wanted to overwrite them, you can do so here. And then you can specify in a dictionary which profiling you want to do. It's currently configured to compatible with Liquid, Prometheus, and Linaro Forge. How to use each one of those with your scripts is on the GitHub page. Here the example is Liquid and Prometheus. The Liquid script, I'm using it on an HPC system that requires me to load one API as well as Liquid, so I've put in there module load as the requirements. For Prometheus, I'm using a local version, so I've basically told it where that local version is located. The structure that you need is described on the GitHub page. Then once I've created that object, I can go and use the submit function, passing it the object I created, telling it what I want the work script and profiling scripts to be called, any bash options that I might need to give to the work script. I can then also have the option of leaving the scripts in case I want to inspect them to make sure that they came out as I wanted. If you don't have this, it will delete the scripts after submitting. And I can say if I want this to be a test or not. If you say yes to test, it'll show you which command it would have used in order to submit the script on your behalf. If you don't set test to equal true, it will just submit the script on your behalf with what it believes is the correct way to do it, either Slurm or Torque at this point. So then the output, this is what the work script looks like afterwards. Looks exactly like the first one because Prometheus and Liquid don't require any changes in the actual work file, but the Slurm options have been removed. And I don't intend you all to read everything that's here, but I'm just going to quickly run through the profiling script, which now has all the options that you previously had from your work script, as well as any additional ones you've defined in the Python. And it also does all the initializations it needs. So Liquid doesn't technically need to be initialized other than module loading. However, what I've done here is I've made it so that it runs a bunch of the micro benchmarks before it runs the work script so that you can plot a roofline model using Liquid. And it creates the directories where it would store all the files for that. Then we go on to the Prometheus initialization, which is basically just starting Prometheus on a specific IP address. There is an option that you can also latch on to existing Prometheus instances if the HPC system you're using has that and allows that. But other than that, it just creates the directories necessary and launches Prometheus as well as node exporter so that you can get basic metric scraping from it. And then it actually runs the work bash script that has been created with the bash options that you had and the liquid command that is necessary before then wrapping it all up and starting the plotting for Liquid as well as for Prometheus. So then the examples of plots that you get out of this. For Prometheus, you get a small time series database and a node exporter metrics from it. These, I understand it's just metrics, it's not actual profiling tool, but this was meant as a low overhead initial starting point. So a low barrier of entry for potential new users who've never profiled anything before. And it scrapes the CPU usage, RAM usage. If you're not using network storage, it also scrapes the IO usage, and it does also monitor network usage, and you can determine the intervals in the options for Prometheus. I combine it with timestamps with some of the original workflows that I was creating this for. They use something called common workflow language where I can get the timestamps of when which step is actually being executed. So the PyProf queue is compatible with that kind of setup and will then plot for you shading, so you know exactly which step is being performed when, so that you can see which resources are being used when each step is active. I understand that this is a bit messy. Ignore the bottom part. That just outlines which steps are being executed when, and there's a lot of steps because it's an astrophysics radio astronomy pipeline. But this is the average CPU usage. Red indicates where you have I/O weight. So if you have a significant amount of I/O weight, the CPU is unable to perform its tasks because it's waiting on reads and writes to the storage. And here we can see the different kinds of shading that happens. So if someone were to use this for profiling sakes, they could say, oh, well, this step used on average across all the CPUs that were available 70% of the load roughly. This is equivalent to the percentages you'd see on top, so it's not the actual flops that you're calculating, it's just the CPU load usage. You can also get, this is for the same astrophysics pipeline, but using significantly less data so that it's less cluttered. And here you can see that the predict step in this workflow is taking up the most amount of time, but it's actually not using that much of the CPU. This is because only a couple of the CPUs are being used, since it has a significantly less data. But you don't see that because this is just the one CPU. This is just all the CPU average usage, but you can get the full each individual CPU usage, which you can see here for the large data set. We can see that there's a significant amount of I/O weight for the latter halves, which is drastically hampering the progress. And for the smaller data set version, I don't have the plot here, but it is essentially just 1 or 2 CPUs that are being used, which is why this average is so low. But we see the predict step is taking the most amount of time. So if I were to optimize this code, I would probably look at the predict step first to see if there's any gains I can make there, because any amount of gains I can make there is going to make the biggest impact on the time that it takes to execute this code. So we can then also look at the RAM usage. Potentially because of the colors and how they turned out, I just couldn't figure out how to change it without changing the automation, sadly, the color and shading automation. But we can see that the RAM usage is very low until we get to the very last step, the 18 clip tar, at which point we spike and nearly triple, if not multiply by 4, the RAM usage as compared to the rest of the time. Again, if someone were to optimize it and they were trying to see if they can run this same code on a system that has lower RAM, that has less RAM than what this needs, I would potentially look at there to see if it's possible to reduce the RAM usage. But this
Marcus,
is just examples.
Yes? Could I ask you to wrap up soon?
Yes.
Please?
Yes, you can. For Liquid, just calculate CPU capability and memory bandwidth. You can do a roofline model, which shows the theoretical performance you should get, and I've made it so that it plots over time, and that is already it.
Oh, brilliant. Thank you, Marcus. Okay, let me see if we have any questions online. Oh, sorry. I can maybe ask no questions online. Okay, I had a few questions. One is, there is a question. I need to find the questions. Apologies. No messages. Oh, I don't see the question.
Okay, yeah, I really liked your talk. I just wondered, do you have any permissions issues, e.g. like reading hardware performance counters that maybe Liquid might need? And if yes, how do you deal with them?
Yeah, so Liquid needs to be set up already. That's one of the few requirements. In terms of Prometheus, you can, most of the time from the systems I've tried this on, Prometheus, you can just run locally. You don't need to set it up with any form of root privileges. Liquid does need to be set up because of what you just mentioned. So I've not encountered it where it wasn't set up, but when I was trying to set it up myself before I realized that it was set up on a system that I was using, I was unable to do so with the little experience I have on setting up Liquid. So I would assume if it's not set up by the sysadmins, then you probably should just ask them to set it up, or you won't be able to use Liquid. That's how I've experienced it.
Okay, cool. I had a quick sort of related question. So if you wanted to deploy this on a new system on Isambard AI, let's say, what are the things you would need to do?
You'd have to make sure that if you wanted to use Liquid, you'd have to make sure that Liquid was installed. You'd have to look at what queue system they're using. If they're using Slurm or Torque, it's already good. And then you'd want to download pip install PyProfQ because it's pip installable, and you'd want to download the Prometheus and Node Exporter directories and put them in a directory structure as explained on the GitHub. Once you've done that, this script, this PyProfQ essentially just creates a bash script for you that can be submitted to a Slurm queue or a Torque queue.
Thank you. Let's thank Marcus. And The next speaker is Samantha Ahern. She's a senior digital teacher research trainer. Thank you, sorry. I looked this up and I forgot. She's also from UCL, so this is a very good session, in my opinion. She's going to talk about, she's going to ask you questions about.
Yeah, so this all becomes a little bit different. I'm going to say not an awful lot of anything, and you're going to say lots of things anonymously via your keyboards. So the first thing I actually need you to do is I need you to join the Menti. So you can either scan the QR code or go to menti.com/43708634. And I will give you a few minutes to get in there. And this code should stay up. If not, I can put it back on for a second. And basically, I've got some really simple questions for you around training and development, around where we are, where do you want to go, and how do we think we're going to get there. So this is completely anonymous. Menti does not collect any data about you at all whatsoever. I will not know what any of you have said. So please, don't be shy. Okay, I'm going to hide the joiner. And how much do you agree or disagree with the following statements? At sufficient time for continuing professional development. I know what continuing professional development myself and my team need. I know where to source it. And the CPD needed is of sufficient quality. Just going to wait for that to slow down a little bit. So we're middling a bit, yeah? It's, think things could be better? Is that the general consensus? Things could be better. Okay. So my next question is, and I'm going to hide this for a minute. Oh, hello. Wrong one, sorry, that's the help. Didn't want to do that. What are your immediate training priorities? So if you are thinking immediately in the next 6 months, what are the things that you need, what your colleagues need, to kind of do your work? I've hidden them so you can't cheat. Okay. So I've been in an awful lot of conversations about training this week, including this morning already. Yep, so SPAC, GPU acceleration, interpersonal skills. I really don't like soft skills. It hides the fact that it's complex and messy. So I'm going to say human and interpersonal skills. Project management, EDIA, community management, yeah. Fortran developers to understand C++. For those of us that are C++, why is usually what I say when I talk to anyone about Fortran, and someone shows me what's perfectly legal in Fortran. Okay, if you learnt Fortran first, brilliant. If you come from C++, why? Just why? Yeah, and so on. Maths, yeah. Coffee is good. Optimization and so on. So that there are kind of repeating things, I think. And some of this I'm starting to see. I'm aware of things, but maybe not so much. So, and I guess now I want to kind of think about that slightly longer bit. So what are you seeing? What are you thinking 18, 24 months down the line? Is it going to be the same? Is it going to be slightly different? Are there going to be things you're going to need to consider? You know, is Copilot going to come into your workflow or not? Could be entertaining. Is there shiny new hardware that might need something slightly different? Yeah, LLM and stuff. I'm actually in a conversation tomorrow about literacies and AI and computing education. I have to get a train at 6:43 to get me to Manchester. I did not plan well. Rust, yeah. I'm hearing a lot about Rust. Omelets, yeah. Is that something specific, or are we literally talking like eggs? I don't know. Yeah, training users of HPC, green HPC. Yeah, definitely. There's nothing wrong with C++. Quantum, do they actually work now? Sort of, for some things, maybe. 26. I actually had a nightmare learning 11 after originally being taught 25, 1995 standard. It was clean, it was easy. And then I had to learn 11 to teach it, and I just went, okay, I get why people don't like it anymore. And Python is just wrong. It's useful, but it's wrong. I will put that out there. Okay, so, right. You can do a bit of think, pair, share with this if you want before you add things. That means you think to yourself, you chat to your neighbor, you share on the screen. Okay, so I'm going to give you a few minutes to talk to your neighbor, think about some barriers, type some things down, and then we can have a look. Yeah? Yes. Barriers to your CPD, professional development. So that could be anything, your time, money. It's not there yet. Have a chat. That's my laptop. That should be the right one. They should be doing this in real time. Okay. Oh, things are magically appearing. Oh. Do we not love Python? No? Lack of training, time, energy. Management. One can self-teach online. I say that really depends on how good the resources are. No overarching leadership or guidance. Yeah, we're working on that. There definitely will be some coming from the society. We have a SIG. Me and Pip have a plan. World domination. Okay, so that's all well and good. But what are we going to do about it? And this is the real one. So what can we do together as a community to actually address some of those barriers? So have a chat with your neighbour again. What can we do? Right, I'm going to hide that because that's not very helpful, is it? It's all well and good, but it doesn't actually get anything done. So proactively, usefully, what as a community can we do? Or start to do, or what do we want to see being done? Yeah, that depends. Sometimes you just get labelled as a moaner and then ignored. I mean, usually my face has said something before my mouth does. Gets me into trouble all the time. Or I lose patience and maybe say things that I probably shouldn't. Sorry.
The people online can't see you.
They don't need to. Okay. Sorry, I move too much. Yeah. Fabulous. Money. I don't know who I got to give money to, but that could be interesting. HPC carpentry. So that gets quite difficult. In what sense HPC carpentry? So we can teach people to use a specific HPC, but are we looking at more of how we code things to run on a HPC, which might be more universally useful? Standards and qualifications. What is it with the omelets? Yeah, free up CPD time, collect high-quality training resources. I really should have moderated this, shouldn't I? Really should have moderated it. Take ownership of your own future. Yeah, make use of development plans. Decide what things are worth training. Yeah, exactly, all of that. So, with that in mind, other than, no, we are not going to go immediately make omelettes, what do you think should be our next steps proactively? Are you going to lobby trustees of the committee? Are you going to request that some things are more digitally accessible? Are you going to suggest an incubator lesson? Are you going to come and tell me all the things you want to be in a software carpentry curriculum later this afternoon? I am the co-chair of the Software Carpentry Lesson Programs Governance Committee. I have the power to bring things through the incubator to the lab, to the curricula. Well, with some other people, not just on my own. And I need to stay here because I'm going to get told off again by Becky. I don't want to get told off by Becky. Right. So how are we doing? Yeah, community coordination, discuss CPD. We have a training SIG. Document success stories. I think that's really important. I mean, you could just go to the shop and just buy the eggs instead of the chickens. They take an awful lot of looking after. Get employers to buy in training development plans. From experience, that gets interesting. Buying things in, it's probably better to work out what you need individually and source it. Ring fence time is definitely that. And certification. So with that, it is now time pretty much to wrap up and move on to the next bit. And thank you.
Thank you, Sam. So I'm going to hand over to Nick for the panel. If you have questions for Sam, ask them to the panel.
Thanks. So what I would ask is that the panelists, so it's Samantha, it's Juan, Marcus online, so it's nice and easy for yourself, Marcus, and Irini. If you could, people in the room, please just come to the chairs in the front. And Marcus online, I'd ask that you just sort of demute yourself and whatnot, so hopefully we can see you on the screen up ahead. Right, so we'll just take a seat in the room. So this is the community training panel. So I think Samantha has perfectly led us into this with lots of things to consider and lots of things to talk about. What I'm actually going to ask the panelists to do is to very briefly introduce themselves, maybe 20 or 30 seconds each. Just tell us who they are and a little bit about them. I appreciate I've put them on the spot. So I'm going to give them a moment, just have a quick think about who they are. Just while I tell you two things, UKRI have asked us to tell you this because I think that people in the room might be interested about these two opportunities that have gone live today on the UKRI funding website. So they've asked us to tell you about the Digital Research Infrastructure Skills Hub for Accelerated Compute, and they've also asked us to tell you about the Championing Knowledge Exchange for UK Computational Sciences opportunities. And as I say, they're on the UKRI Skills Hub, UKRI funding opportunities went up today. They thought they'd be really applicable to the people in the room. So just wanted to make you guys aware of that, and then it's posted in there. So now I've given people a chance to have a think about who they are. What I will ask, let's go first with yourself, Marcus, online, if that's okay. Hopefully the IT is all working. So over to you, Marcus.
Yeah, so I'm Marcus Kyle. I'm an RSE at UCL in the computer science department, but I have a background in astrophysics, and my work now is actually working with the Square Kilometer Array Telescope, but as part of the UKSRC effort of it to help teach people how to profile and optimize their codes so we can actually use our codes with the upcoming data, which is going to be very large data sets.
Brilliant. Thank you very much, Marcus. We will start on the far side. So, Juan. Oh, sorry.
Hello, everyone. I'm Juan Herrera. I work at HPCRSE at the University of Edinburgh. I'm the Archer 2 training function lead. That means that I'm organizing the training courses of the to learn a little bit more about supercomputer, about the also gain some the skills that you need to do some software properly and decide what courses, when, where. Well, that's me. I'm going to the next Irini.
Thank you. Hi everyone. My name is Irini Zorumpa. I work at Imperial College London as a community manager on the Universe HPC project, which is working to create a training curriculum and kind of training pathways for RSEs who are interested in getting into HPC. My background is completely unrelated to all of this. I was a psychology PhD, and I, in a more less technical, I guess, field. So I spent a lot of time training early career researchers, the basics of reproducibility and programming and version control and all of that. So that's my comfort zone, talking to beginners, not research software engineers. So keep that in mind, please.
Yeah, Samantha Hearn. My official job title is Senior Digital Research Trainer. I co-lead the education activity in ARC at UCL. So in that, I sit on our doctoral training board. I sit in our Open Science and Scholarship group, and I work with the Research Culture Steering Group on things. My degree is in computer science, but professionally I'm an educator. It's what I've done for 20 years. I was originally a teacher. Beyond that, I'm a STEM ambassador. I'm now a trustee of the society as of yesterday, because I thought that would be a good idea. And I've been involved with the carpentries for a long time. So I'm an instructor trainer. At one point, I was on the Code of Conduct Committee, and I co-chair the Software Carpentry Lesson Programs Governance Committee as well. So I work with Toby quite a lot on the curriculum and how we're going to develop that curriculum. And internally, I support colleagues in developing their training and train and work on developing them as educators as well.
Brilliant. Well, so a request to people in the room, please do post questions via the canopy. You know, let's have some great discussion going on. I'm going to start us off with something. When we were preparing for this session, one of the comments was, you know, sometimes we struggle to attract attendees on some of our advanced training courses in and around EPCC, and Juan, you'll probably know some of this a lot better than me. Do we offer too much training, or is it too uncoordinated how it's all out there? I don't know if anybody has any views or comments about that.
I think training is best when it's just in time. So I think you need a mix. You need a mix of stuff that's on demand, that's well facilitated, so it's either incredibly well structured that they can do it on their own, or it has some support element to it. So whether that's some form of drop-in that's scheduled that people can go to and ask questions, or you have a regular program of things. Now, those in-person things are incredibly expensive to run in terms of time and people, but a good mix. But I think knowing when the community kind of needs it and having an idea of what's happening when with projects would really help.
Yeah, I agree. I think it's a good idea to have several ways of offering training. That one could be face-to-face, online, self-service. Also, some the training could be 1 day, 2 days, 3 days, or even half a day. So I think the key to attract a more offer or be more diverse from the point of view of training is to offer different formats, different lengths in order to attract people that are lucky and have more time to do the training, or people that are more time constrained on the limits that.
And obviously online, Marcus, if you've got anything, just jump in and feel free to interrupt us. Sorry, were you going to say something?
I had a question. You said that you struggled to, I know, I'm flipping the table. You said you have trouble attracting people for the advanced training. That sounds like there is beginner training. Is that well attended?
Well, Juan would know better.
I would say, yeah, that, or maybe it's because for instance, for the introductory training is, software carpentry, data carpentry, HPC carpentry. Normally these ones are well attended, and for the advanced courses, some of the courses it's a mixture, to be honest. It's not but yeah, maybe it's also what, according to my, short experience training, what I found that is important, like the title of the description of the training, that sometimes you do a small change in the title and you attract more audience to that training. But yeah, it's a question that I still wondering myself.
I've got a follow-on question from actually somebody in the audience, so maybe this is something that feeds into this. Somebody's asked whether it's a bit of a chicken and egg scenario. You know, there might be a centre that doesn't have many HPC projects, nothing particularly interesting to work on, but they've decided we need HPC expertise. And the problem is people then go away, they get the training, but then actually, where can they use it in anger? But of course, it's chicken and egg. If you don't have that in the first place, how can you get these projects? Is this something that is shared between other organizations? Is this something that the panel see at all in any of their interactions with people?
I can actually say something to that, not necessarily from the point of view of someone training, but from the point of view of someone who attends trainings. When I was doing my astrophysics PhD, I found that more often than not, people would simply just attend the basic training, and then one of two things would happen. Either, like you said, they wouldn't know where they could use it, or they'd realize, oh, actually, I can use it for this thing. But then because of how abstract or less specific some of the trainings can be sometimes in order to teach people the concepts, they would then not go to the advanced training because they would think, oh, I can just train myself in the way that I want to use it anyway, so that they wouldn't go to the advanced training. So it's like, yes, in some essence, they wouldn't go for the advanced trainings, or they wouldn't be able to figure out where they could use their stuff, but also if they couldn't figure out where to use it, but also when they could figure out how to use it, more often than not, they thought, I'll just teach myself because they're not going to teach me to use it in the way that I will need to use it anyway. So kind of, yeah.
Yeah, I could say we've got a bit of a training gap. So we do, you know, intro stuff in carpentry. That's great. We teach them literally how to interact with the HPC. Like, this is how you submit a job. But we don't really teach them how to write the code that will run well on the HPC. And then a lot of kind of the advanced stuff is then, some of it's kind of beyond that. So even to understand kind of MPI and stuff, that, you know, there's a bit more knowledge that you need in between the basic, even to that bit, that I think we kind of miss. So there's this kind of bit of like real novice stuff. And then there's the more, it's going to make your head hurt stuff. And then there's not really the bridging bit in between. And I think we're kind of missing that, really. Because it is quite a jump sometimes for people, especially if they don't have a computational background and they're coming from other disciplines and things. And it shakes your confidence a bit. And maybe you kind of shy away from it and don't engage in a way that that might be, you know, most interesting for your research.
It's an interesting point, and maybe slightly tangential, but I thought very interesting for your talk. One of the responses to maybe what can we do better is, I'll paraphrase it, but don't mock people's choice of technology. I mean, you know, we say it in jest. I mean, earlier we were joking about, oh, don't use Fortran, I'm not going to say any more Fortran. But, you know, for most people that's fine, but you can imagine for some people, actually, they could take that the wrong way. And if they already feel that they've got some gaps in the skills, actually that becomes a bit of a problem. So, you know, it's an interesting thing more generally how we do that messaging, isn't it?
I could say that the golden rule in carpentry is don't diss. Don't diss an OS, don't diss a piece of software. I know there are Fortran users in here, and I was joking because I know that actually we're all really experienced coders in here, but if I'm talking to people in a training context, then that is a very different thing. And when I'm delivering instructor training, that is something that I really put across, is that, you know, most things are valid. And if something is, there are ways of suggesting there are better ways of maybe doing something that are nice, then, yeah, kind of pointing and laughing at someone.
So we're getting the questions, which is great, quick and fast. One question, and maybe we've covered this, but I do want to bring it up explicitly. Somebody's asked, are we mixing up our wish list versus what we actually need in the training in the roles? And I suppose I would paraphrase that by saying, you know, do we spend enough time out in the community making sure that the training we're delivering is actually meeting the needs of the community? And maybe it goes back to what you were saying on the gaps and some of that.
So on the step up, that is definitely happening. We're actually looking at JDs and looking at people's pathways, and we're going to try to talk to people about how they are developing, to, you know, and then we want to map what already exists against that, and then identify what is missing, because there was a piece in the project plan that just said magically make training, and I was like, nah, we're not doing that. We actually probably need to do a bit of work with the community, and I was kind of saying that this morning in the SIG, that there are an awful lot of overlapping projects that are doing overlapping things, that actually maybe we need to do this together as a cohesive conversation. And also think about, you know, what are we applying for money bid-wise? You know, think about what is coming in terms of the skills that we need to work on those projects. You know, are we talking to our community and our institutions about the things that they want to do and how they see their research going? So we have a community function within ARC. I'm trying to work with them. It looks like I'm probably going to some biology thing in October, because they're going to be talking about their research, and I want to know what it is that they want to do so that we can think about how can we support them in terms of skills and training, and do we need anything different? You know, is the messaging wrong? I don't know, but that's conversations with the community to find out.
Yeah, and I wonder if this also relates to what you were talking about before, because to know the training needs of a community, you also need to know who is and who you would like to be in your community, right? So as I said, I'm from a psychology background. Not many people use HPC, and I think there's a lot of intimidation, right, that people feel when it comes to really getting into those more technical topics. So I wonder if there's quite a bit of outreach that actually needs to be done to go to fields that maybe, you know, HPC hasn't historically interacted with as much, you know, humanities and, you know, social sciences, because there are overlaps there where HPC could be useful to them, but it is, you know, understanding how it could be useful and then, yeah, feeling welcome. I think that is a big side of it. Yeah, sorry.
No, that's yeah. I think that's a good point, and yeah, I think that also like to design a training program, we should get into account the feedback of the users of what courses they would need to they would need to attend, and also like a more proactive approach of from the training providers to say, yeah, which courses are needed. Also like a kind of advice to them to that there is a lot of work done of well, also ongoing about the training paths or yeah, defining if you are in one stage of your learning path, what's next.
So we've had a couple of questions on this, and I think it's an interesting point. So we've been asked, you know, how or is it useful to measure the impact of training? And then related to that, you know, do we have evidence case studies on the return of investment and actually the impact that training and CPD makes on people?
Yeah, so there's a thing called the Kilpatrick scale for evaluation, and a lot of what we do is kind of at the very basic level, because it takes longer term, and you want to look at that longer term impact. So, you know, we tend to survey people before and after training. What we don't do is we don't go back 3-6 months later and actually see, and that's the kind of thing that we need to be doing, is that much longer term thing. I'm hoping to get some money to look at doing some training around narrative CVs and using that to promote FAIR. And in that plan I put that, yeah, great, I'll do some immediate survey feedback, but I also want to go back 3 months later and see what's actually happening and whether that's made a bit more of an impact. And then I guess on the ROI, I mean, if you're going to be crude about it, you know, what grants have you secured? How successful was that research? Have you put something in JOS? You know, are you able to kind of collaborate in things that you weren't able to collaborate with before? You can look at people's progression in their career, potentially, that kind of thing. And then on the soft side, you know, are they then engaging and contributing back to the community? Are they assisting in and leading training in this? Are they advising their colleagues? Are they assisting at drop-ins with people, that kind of thing? So it also depends what you value as the ROI as well.
And one thing, I mean, measuring impact is always really difficult. And I think it often is done best in kinds of data that we're not always comfortable with, which is qualitative data. Yeah, this is something that I'm trying to get better at, but you know, like, how do you analyze qualitative data? I feel like that's something that probably almost no one in this room is training in.
Well, I was going to ask, is this where maybe other areas like the arts can assist us more?
I believe so. So, as I mentioned, I'm a community manager at Imperial. I'm also a quantitative researcher at the Royal Society of Arts. Sadly, nothing to do with arts, but there are a lot of designers, and they know so much about thematic analysis. I was like, ooh, this is a skill I've never trained. And I think when it comes to evaluation, impact, dare I say, theories of change, we really could be learning a lot from those sides of, you know, the arts and sciences.
So actually, the project that Marcus is working on, the FAIR stuff that I'm going to hopefully be doing some stuff on, comes from there. And they're actually working with experts in behaviour change, behaviour management, and looking at using their knowledge in the design of training to kind of shift that along. So there is a lot there, and yeah, qual is a skill in and of itself. That there are several ways of doing that. You know, you can do sentiment analysis, you can do thematic analysis and other things, and that's not an easy thing. So I did have someone come to drop in and go, yeah, I've got this stuff I want to analyze, and there's this thing called NVivo. What do I do? And I'm like, do you even know what your themes are that you want to analyze first? That kind of helps. So there is kind of a process to this, and you know, there are tools that can help us, but there is real expertise, and yeah, we should be leaning on our colleagues and working with them on this.
On that, I can actually make a comment, because I was able to take advantage of some of the people I work with that look more on the cultural side of things and don't have a physics background. That's why PyProfQ was developed. It was meant to be, they suggested if you make it as easy as possible to get into profiling, then you can help start a cultural change to get more people in the community to actually start profiling. So that's why PyProfQ is meant to be as easy as possible to use, even if it doesn't give you all the insights that profiling would give you. And I think even when showing people how to profile and such, it's difficult for me to say, okay, I've actually taught them something, because they may not use that profiler again, but they might look at the way that they code in a different way as compared to before. So they may not profile, but they may have learned something else in the approach that I showed them that impacts how they code later on. So it's very difficult.
And in other fields, people don't know what they don't know. You know, it's not until you have conversations with people about what they're doing and how they're doing it that things start to kind of appeal, and you can kind of look at alternative ways of doing things.
Great. We've had a few questions on this theme, so we've circled around it, but I want to bring it up explicitly because it seems quite popular. Do we need more staff time dedicated to self-directed learning? Most interesting for me on this question was the working on the side projects, and how to convince managers to allow funding for that. And related to this was, you know, how can we allow people to learn on projects when funding tends to only be given to people who are already experts in these areas? Sort of that career mobility again, you know, how to actually give somebody a chance to do that when they're not an expert. And then lastly on this point, I say there were 3 questions on this, was, you know, it's really useful if there is buy-in from the employer. It gets difficult when it's some new topic or an intermediate requirement, and there's not a lot of evidence that this is immediately beneficial to this individual person, maybe because that project already got somebody on it, on that. I don't know if there's any specific views on the panel on these themes.
Well, I think almost everyone maybe agrees that, yeah, I think, yeah, do some training or like yeah, attend some training is good to keep up to date with the new technologies that every year there are new ones. And I think as well as we spend time, I don't know, filling a specific form, replying to emails, etc., we should schedule some time for training. And maybe that's also, I'm talking about myself, the mistake that I'm making, that is not, we don't schedule that training or have like one time during the week that, okay, these 2 hours I will sit down and read a little bit about this new technology or this other. The problem with that is also that, like, yeah, maybe the workload that you have is quite high, but yeah, that's also another thing that maybe the manager should keep an eye, or maybe have a better communication with your line manager and say, look, I would like to learn about this, and I would like some time scheduled for that. But yeah, this is an idea work, but yeah, that is a tricky question of what is something that I guess that we should get better at some point, hopefully soon.
Yeah, I'm going to say it's time. So over the last 6 months, I've supposed to have been learning AWS. I've epically failed to get past the Cantrell intro because other things have happened. And in a way, I've let other things happen. So it is a priority thing. but it is also, it does require that buy-in and that space and time, and it kind of needs planning in as well. So, you know, if you're going to work with people on a project, factor in extra time, if possible, to kind of bring people along with you. It's easier said than done, I know this. But it is that bit of, as Richard Branson said, train them well enough they can leave, but treat them well enough that they don't want to. You know, if people don't get developed, they don't have that opportunity, they're not going to want to stay. And their work's not going to be that enjoyable if you're just doing the same thing over and over again and you're not growing. I found that myself. So it's that bit of also creating a good work culture for people where they feel valued and developed. You know, get it in the development plans, have those conversations with them. You know, that there should be regular check-ins when you do your line management meetings against the development plan. Add it in, switch things around. It is time, it is money. Some of us have more luxury of that than others. I know that. I know that in larger groups we have slightly more wiggle room. We do usually have more work than we have people, but we can usually work something out. So it's about will, I'd say, more than anything else. You know, where there is a will, there is usually a way that things can get worked out.
So just take us to the end of the panel, last couple of minutes. We've had this question a couple of times, so I do want to bring it up. Training, you know, very heavily classroom, workshop, tutorials. It's a well-known format. A number of people have asked, actually, you know, is this really the best way of doing it? Are there better formats, better delivery approaches that we should be aiming? Especially somebody said for more advanced training, but maybe to help with some of these time constraints as well. I don't know if the panel have specific views on that.
So, for instance, I will talk about our case, but yeah, I guess that for the carpentries that traditionally are 2 days, 2 full days, but well, for instance, when we we deliver the training online during 2020, 2021, you can imagine why. This, rather than having 2 full days sitting down in front of a screen, etc., we decided, okay, let's try 4 mornings or 4 afternoons. And actually, I think that approach worked well. Other approaches that we have tried is rather than these 2 full days could be 2 Tuesdays or 2 Wednesdays. So have like a week between the first and second day to do the exercises. I mean, it's different. For instance, when you travel to a place somewhere else, yeah, you need rather than having 2 different days and going back, etc. Yeah, it needs to be like everything in one go. But yeah, we always try different approaches and play around to see which one is the best. I don't know, but well, the experience me said that yeah, that everything in one go is a little bit challenging. So also giving time for breaks and leaving like idle time. Yeah, time to rest or to catch up or do exercises, etc. is essential.
Yeah, I agree with experimenting, especially for things like carpentries, definitely. I do think a synchronous element to training is really important. I don't think it's going to be a new thing for people to hear, but you know, you start online training by yourself, self-paced. You do 1 module, maybe 2 if you're really good. I did finish 1 Coursera course. I have started double digits for sure. Like, without that accountability, I think you need to be either extremely driven or extremely driven. I don't think there's any other, like, it's common mortals, I think, do not finish things if there's no accountability. So unfortunately, perhaps, because, you know, like synchronous training doesn't scale very well, it takes up your time and all of that. It's not very convenient, but it is sadly, I think, the thing that works. But I think you're the more experienced educator here.
Have to be quite quick.
Yeah. So we experimented with a few things actually with our intro to HPC. So when we do it physically, 2 people, like 2-day delivery, the numbers are very low, they're less than 10. We've tried it online with an asynchronous element and then a synchronous session to then come up with and answer questions on that. And what we're finding is that people weren't actually doing the pre-learning to come prepped to the session. So flipping, because effectively they don't see consequence of it. And we do this with lectures as well. We completely flip out our lecture, and if they come to the live session, we actually say, actually just read the material, because you can't do the lab, which is the live lecture, if you haven't actually engaged in the material. But when it's the HPC stuff, because it's there, it doesn't matter. So we've kind of gone to the, look, it's there, it's on demand, and if you have a question, come to a regular drop-in. Because that, you know, us taking, you know, 4 lots of 2 hours for no one to turn up or them not to have done work and have anything to ask us doesn't scale. If you're going to do on-demand stuff, doing that well, really well, designing that really well, takes a lot of time and a lot of money. And you need really good self-assessment in there to keep people engaged. So it depends on what you want and what the need is. And this stuff changes. So, you know, and we were talking about this, that you want no more than 5-10 minute video segment, because you're going to have to switch them out on a regular basis. And that maintenance is important. I mean, we built some online courses. The Unix shell stuff doesn't really change, so that's good. But the Python stuff, I mean, we haven't really touched it for 6-7 years, and we've just shelved it now because we haven't maintained it. We know we haven't maintained it, and we know we need a lot of work. So we've actually kind of quietly retired the self-service, because actually, for a lot of what's in there, they're either going to come to a carpentry, or some people will just kind of find things. And there's an awful lot of content on LinkedIn and Coursera and other platforms as well. And it is that bit of, right, if you are going to do this self-service stuff, you really need to schedule in the maintenance of this and be really on top of it all the time. And this is a conversation that we're actually having. We're creating some material we're working with some people to create some material for them, and we're actually having that discussion about the maintenance and going there. Actually, the current videos are definitely too long, and, you know, we could do a lot of upfront now, or we can kind of do it later. But it's that, and then making sure all the accessibility bits are there. You know, if you chop a video, you've got to retime all the transcripts and the captions, and that takes time as well. So yeah, it's just being really mindful of that and having that real clear journey as well, and not too much cognitive load. So you have to really clearly structure that pathway through the material and make it incredibly explicit. So it is an awful lot harder than your standard in-person delivery.
Well, unfortunately, we're going to have to draw it there, just in the interest of time. A lot that we've talked about, but clearly a lot to unpack. So I'd like to thank the panelists for all their knowledge and insights that they've shared. Samantha, Irini, Juan, and Marcus, who's joined us online. I know you guys are going to be around for the rest of the day, so please do grab them and continue the conversation, because there's quite a bit of stuff we've not had a chance to talk about, so I'm sure they'd be very pleased to do that. So please join in me to thank and give them a round of applause. And we're now going to hand over to Ed, who's going to wrap things up for us. Thank you. Brilliant. Thank you.
Yeah, just want to echo what Nick's just said. Thank you, everyone who's here for contributing today. Particularly like to thank the speakers, those for the lightning talks, and obviously for the sessions this morning and just now. Without your contribution, obviously we'd have no session. And I think that the talks are really, really interesting, and obviously from all of you to contribute by adding your questions led to some really interesting discussions. So thanks ever so much, and we're really keen to hear your feedback. The way we're going to do this is with sticky notes. So essentially we have some at the beginning, at the front of the hall. Because everyone's just going to pile in here, we're going to leave them on this table, and you can pick them up anytime, like during the lunch break as well, and we'll pick them up, essentially stick them on that wall. Yellow for positive, red for things we'd like to change. Please be constructive. Like I said, put them on there anytime during the lunch break, and we'll try and pick them up before the afternoon session starts. We are planning to have another online meeting during the winter. So if you want to get involved with or helping to organize that, or you want to contribute in any other way, please get in touch with any of the organizers. and we'll hopefully be able to continue some of the great discussions over on the HPC channel on the RSE Slack. But if you wouldn't mind, please join me again in thanking everyone who contributed to today's session.